Hello, I'm Jonathan. We are Team 38, a well-tempered accelerometer. This is video blog 1 of semester 2. What we learned from last semester through trial and error was that finding position through the use of dead reckoning alone was not precise enough to get a map estimation of the device. Through research, we discovered that a Kalman filter needed to be used in order to get a better approximation of the location from acceleration data, and also be able to integrate GPS once we figure out the acceleration data map.
Hi, I'm Eli. Before we actually implement the Kalman filter into our project, we first need to understand how it works and what it is. Kalman filter is a complex mathematical process that uses a number of equations and a set of consecutive data input, which are, in our case, it's acceleration data from our accelerometer and GPS data that we're going to implement in the future as well. When the measured values contain an unpredicted or random error, uncertainty, or variation, in this case it does, because when we first semester, when we had an integrated double, like our drift was so far and we had to kind of move us back into position. That's why the Kalman filter comes in to like clean up our data set, and that's what the Kalman filter does exactly. So it takes our data inputs to estimate the true value of position of the object that's being measured, in this case us as a person, or either a car or anything that we want to implement it in.
What we would like to do is take our acceleration data and combine it with GPS data as inputs to the Kalman filter, and then basically produce an estimation of 3D coordinates that are much better, much more accurate and precise than acceleration data alone or GPS data alone. So really the big fish this semester are to put in a lot of research and time with understanding the Kalman filter process, how it works mathematically inside and out, and how to actually use two inputs such as acceleration and GPS. Another challenge will also be to come up with a GPS source that logs at a data rate that is fast enough to keep up with our acceleration data so that it is actually usable with a Kalman filter. So that, combined with translating the mathematical process into Python code, will be the biggest challenges of this semester. So hopefully in the next video, we'll be experts on the Kalman filter and be able to produce very precise 3D trajectory maps.
Hi, I'm Billy Hardiman. I worked on a lot of the GPS, which is the other aspect to the Kalman filter, the input, along with the acceleration data, which outputs the more exact location signal, which is our final goal for the project. Last semester we did some research on GPS initially, and we found it to be able to get it accurate to about a couple times per minute, which was way too slow for the 150 to 800 hertz signal we get from the acceleration data. So I did a little bit more research into the GPS and was able to get that down to a point every second, which is an improvement, but we would like to get a little bit faster. So I'm currently working on other ways to record more accurate GPS data to go into the Kalman filter